graph the solutions to the system of inequalities below. So we're given two, in this case, linear inequalities. In the first case, y is greater than or equal to 2x minus 4. So at the negative 4 there is our y-intercept, so put a dot here at negative 4. Our slope is positive 2, so we're going to go up 2 over a unit, up 2 over 1 unit, up 2 over a unit. And grab our ruler, and because this was or equal to, right, this is a solid boundary line. So I can draw this. This is my boundary line. The next, and then the other thing is if I test a value, if I test 0, 0 in that, 0 is greater than negative 4. So, and also it's generally saying that the y's are above this curve, right? The way I'm reading it, y's are greater than the 2x minus 4 line. So my y's are all above. So, and also this point right here, 0, 0 tests true. So for this line, we're shading above it. The next one has a y-intercept at positive 4, and it has a slope of negative 5. So I'm going to go down 1, 2, 3, 4, 5, and then over 1 unit, and then down 1, 2, 3, 4, 5, and over 1 unit. So it's a negative slope, and it's pretty steep compared to the other slope. And this is not an include boundary line, right? This is strictly less than. So my boundary line is dashed. So I'm drawing this as dashed lines. And if I was to test this, this says y's are below this curve, right? Y's are less than that. And if I test the point 0, 0, my favorite point to test if I can, when I put 0 in for y and 0 in for x, it says 0 is less than 4, which is true. So it is below this curve. Right. So I'm looking for spots that are above the first curve and below the second, and I'm saying curve, but they're lines, right? And this is the region. Anything in this region is a solution to both inequalities. So there we go. Any of these points, you could just go on forever. They're all points that would work. Meaning, let's just be real clear. If I was to pick a particular point like this one right here, if I picked x as negative 4, y as 1, it would make both of those true simultaneously if x was negative 4 and y was positive 1. If I put that in, 2 times negative 4 is negative 8. And negative 8 minus 4 is negative 12. And guess what? 1 is greater than negative 12, so it works there. If I put negative 4 into the second equation, that's a positive 20 plus 4, which would be 24. 1 is less than 24 is also true. So all of those will work. Points, however, in this region, or this region, none of those points would satisfy both equations. They may satisfy one of them, but they wouldn't satisfy both. Only those in the purple region are solutions to our system of linear inequalities.